Team, now it's time to talk about why raw. Why do we do what we do at Stella and Chewy's? The whole entire philosophy is based on what's called the prey model philosophy. Why am I talking about prey? Because this whole entire philosophy is based on what the wolf would eat out in the wild. It's not like the wolf is chasing 30-pound bags of kibble with 4 legs or chasing oversized canned food rolling down hills. They're chasing prey. And so that's why we do what we do. Daryl, why are you telling us about wolves if dogs aren't wolves? Well, that's not so. Dogs are actually wolves. Before 1993, dogs and wolves were categorized as 2 totally different species. The wolf, Canis lupus, and the dog, Canis familiaris. But the science community was debating about this until a doctor named Robert Wayne at the University of California, Los Angeles decided to put the debate to rest. Dr. Wayne wanted to test the genes, not the genes that you would buy at Men's Warehouse for buy one, get one free, or Lucky Genes. I'm talking about the DNA. There's 2 types of DNA that Dr. Wayne tested. He tested the nuclear DNA and the mitochondrial DNA. Let's start off with the nuclear DNA. The nuclear DNA has to do with what's going on the outside of the animal, bone structure and size differential. The one we want to focus on is the mitochondrial DNA. That's the DNA that's passed on through the mother alone. When Dr. Wayne tested the mitochondrial DNA of the gray wolf and the dog, they found that there was a 99.9% similarity between the gray wolf and the dog. Why is that important? Because the mitochondrial DNA is intrinsically linked to the animal's physiology, their GI tract, their metabolism, how they digest food. The science community decided to change the classification of the dog's scientific name. Remember, the wolf, Canis lupus, and now they changed the dog to Canis lupus familiaris, the domesticated wolf. So since there's a 99.9% similarity between the gray wolf and the dog's physiology, let's talk about that. Let's talk about their GI tract. Everything having to do with digestion starts right here, in the mouth, in the teeth, in the jaws. Us as humans do something called chewing. The technical term for that is mastication. We're able to chew and we have a flexible mouth that our jaws go side to side. The dog doesn't have that. We have to chew our pieces down into really, really little pieces to help us with digestion. Again, we masticate. But guess who does it? The dog. The dog's jaws are a stiff hinge. They only go up and down like this. They cannot chew. Their jaws are meant for nothing more than grabbing, tearing, ripping, and crushing bone. The second major difference between us and the dog is in the saliva. We have an enzyme in our saliva called syllabic amylase. Amylase breaks down carbohydrates and starches. The dog and the wolf don't have that because out in the wild, they're not hunting carbohydrates and starches, they're hunting prey. So the dog's saliva is nothing more than a lubricant to help it get from point A, the mouth, the teeth and the jaws, down the esophagus and into the stomach. So we talked about the mouth, the jaws and the teeth. We talked about the saliva. Let's now talk about the stomach. As humans, you always hear our stomach is the size of our fist. Our stomach is meant for pre-digestion. It's about 20% of our GI tract. A dog's stomach is different. It's not 20%, it's not 30%, it's not 40%, it's actually 70% of their GI tract. It's a very, very large organ and it's meant to be filled. Just to put things in perspective, guess how much an 80-pound fasted wolf can put down in 30 seconds? 22 pounds. That's how big the dog's stomach is. A wolf won't stop eating it until they're fully satiated, until they're full, and then they'll rest. Now that we talked about the GI tract, let's talk about what's going on inside the animal. Remember that 80-pound fasted wolf that took down 22 pounds in 30 seconds. He had to grab that prey, he had to rip it, tear it, crush it, he had to lubricate it, swallow it, have it go down into the stomach, and now that food stuff needs to get broken down into its simplest compounds. Every single nutrient is made up of molecules, and those molecules need to be broken down into their simplest compounds in order to be assimilated by the body. Since we're talking about the prey model diet, let's talk about the protein molecules. When the food stuff enters the stomach, it's in a form that's too large for the animal's body to assimilate. It needs to be broken down to its simplest compound. There's 3 steps to getting this done. In the stomach, there's an enzyme called pepsin. A molecule of protein is built up called polypeptide bond. It needs to be broken down into smaller pieces. Pepsin is the first step in this breakdown. That's your polypeptide bond. It's now being broken down to what's called a dipeptide bond. After the stomach is done breaking down the protein into a smaller piece, it then goes into the intestines where the second enzyme, trypsin, breaks it down into even smaller pieces. Remember, it's now a dipeptide bond, and now it's going to get broken down into a peptide bond. And to finish things off, there's an enzyme called aminopeptidase. And aminopeptidase breaks that peptide bond down to the smallest compound called an amino acid. So that's how a protein molecule gets broken down to its simplest compound. And carbohydrates has its own set of enzymes, and so does fats. When you're feeding raw, the beauty of it is the foodstuff is in a form that nature intended it to be. Therefore, the animal's body can do what nature intended it to do. It's all about breaking it down on the molecular level and getting the nutrients down to their simplest compound. Thanks, team. Thanks for watching.